وعلى آله وصحبه أجمعين. This lecture would be exercises about the binomial probability distribution. We said that in a binomial probability distribution, the possible values of x are from 0 to n, where n is the number of trials or the sample size. And x is the probability of, x is the number of successes. And number of successes in the n trials. So I could have 0 success, 1 or 2 up to n. Now, how to find the probability of each x? I use this formula, which is NCX, or we write it like this, as we said before, times p to the power x times q to the power n minus x, where q is the probability of failure, and it is 1 minus p. So this is the formula, and let us go and solve some other exercises. We start by question 527. Suppose that 40% of all home buyers will do some remodeling to their home within the first 5 years of home ownership. Okay, so 40%, this is a probability or a percentage of something. What is this thing here? The home buyers that they are going to remodel their homes within the first 5 years of home ownership. In the first 5 years, they will remodel their homes. The percentage of those people is 40%. Okay. So it appears that the 40% could be the probability of success. So the probability of success could be 0.4 according to this sentence. Let us continue and see. Assuming this is true, use the binomial. Since he said binomial, okay, so this is for sure a probability. And to determine the probability that in a random sample of 20, okay, so this is the sample size. And we have learned that the sample size is called n. So n is 20. Homeowners determine the probability 2 or fewer. Okay, so n is 20, p is 0.4. Determine the probability that 2 or fewer, so the number of homeowners is less than or equal to 2. 2 or fewer. Fewer means less. Will remodel their homes. So he is talking about remodeling their homes. So you can say that x number of people in 20, because their number is 20, who will remodel their homes. Of course, in the first 5 years, as he mentioned. So this is x. X is the random variable. What is the experiment? We will come to each one of these 20 and see or tell him, ask him, did you remodel your home or not? So either he remodeled or not. Okay, so we have two possible outcomes. So it's a binomial probability distribution, independent. If one of them remodeled, it doesn't mean that the other one will do the same. So how to find the probability that x less than or equal to 2? So we know x. So what are the possible values of x? How many people remodeled their homes out of 20? It could be 0 up to 20. So we could have from 0 to 20 remodeled their homes. All right. And this is the probability of success. We know that 40% of these people will remodel their homes. All right. So how to find probability of x less than or equal to 2? Probability of x less than or equal to 2 means you need to find probability of 0 plus probability of 1 plus probability of 2. Because when you say less than or equal to 2, you have 2, 0, and 1. Okay. You can find these probabilities using the formula, but I will teach you here how to find them by the calculator. So if you have 3, 4, 5, 6, 7, 8, 10, 100 terms, okay, you can do that by calculator. How? You use the summation symbol. So you write this as summation probability of x, where x is from 0 to 2. So what do we mean by this symbol? What is the meaning of this symbol? It means you replace x by 0, then you add, then 1, add 2. So it is in fact probability of 0 plus probability of 1 plus probability of 2. You start by 0, you end by 2. Good. How to ask the calculator to evaluate this? Okay, I will first write the definition of probability of x. According to the formula, probability of x is NCX. What is n here? N is 20. Okay. What is x here? Well, x changes from 0 to 2, so I will write it as just x. Then P, probability of success, which is 0.4, and I raise it to the power x. X changes from 0 to 2, times 1 minus 0.4, which is 0.6, which is q, to the power 20 minus x. So please, if you have a calculator, try to put this now in the calculator and find the answer. So there is a summation symbol above the log. So you write shift log, you get the summation symbol, and then you write 20cx. So 20 shift division, because C is above the division. And then you write x. How do you write x? There is x in red above the parenthesis. So you write alpha x. Okay, so now I wrote 20cx. Then I say times, multiply, 0.4, I raise it to the power x. So I use again alpha x. Then I bring the cursor down and I write 0.6 to the power, and I write 20 minus alpha x. And I say equal. The calculator will give me the answer. Okay. I have to write times always between each two of them. Yes, and then you have to mention x runs from where to where. So from 0 to 2. Okay, and the answer would be 3.6115 times 10 to the power negative 3. Okay, what is the meaning of negative 3? It means you have to move this point 3 places to the left. So I'll have 0, 0, 3. So the point was here. I left it 3 places to the left, and then I have 6, 1, 1, 5. This would be the answer, the probability. You can, if you want, you can press Shift Eng in the calculator twice, Shift Eng, and it will write the answer like this. Times 10 to the power 0, of course, and 10 to the power 0 is 1. So that's the answer to this question. Another question, find the probability of exactly 5 successes. So number of successes. Number of successes is what? Is x. So x is 5. In a sample of n is 10, probability of success. What is the probability of success? It is p. So p is 0.7. So what do we need to find? Probability of 5. So what is probability of 5? By the definition, this is a binomial experiment. So n is 10, cx, which is 5, to the times 0.7, which is the probability of success, to the power 5, times 1 minus 0.7, probability of failure, which is 0.3, to the power 10 minus 5, which is 5, and please use the calculator and find the answer. So you say 10 C5, you write it in the calculator, times 0.7 to the power 5, then times 0.3 to the power 5, and the answer would be 0.103. So that's the probability of 5 successes. All right. Another question. This exercise, a bank believes that 80%, so 80% is a probability, percentage. 80% of its customers prefer the bank to close early on Friday, but open on Saturday morning. Okay, so these customers prefer this option, closing on Friday and opening on Saturday morning. What is the percentage of those customers? 80%. Suppose 3 customers are randomly surveyed. So what is this? This is the sample size. This is N. So N is 3 and P is 0.8. 3 customers are randomly surveyed and that the binomial distribution applies. Develop the probability distribution. So he is asking about probability distribution. When he says probability distribution, it means he is asking for this table and he wants all the possible values of X and the probability of each one of them. For what? For the number of these customers who like the Saturday option. So what is this? Number of these customers who like the Saturday option. This is the definition of X. This is the definition of X. So what is the experiment? We will ask each customer, customer 1, do you like Saturday option or not? He will say yes or no. So it's a binomial experiment, okay? And success here is yes, I like Saturday option. This is success. And 80% is probability of success. And number of successes out of 3 would be 0, 1, 2, or the 3 customers will like the Saturday option. It could happen. So we need to find the probability of each one of them. For example, probability of 0 would be, we can write the definition of probability of X in general. So probability of X would be as N, which is 3 CX, CX. So 3x, okay, times P 0.8 to probability of X times 1 minus 0.8, 0.2 to the power X here to the power 3 minus X. So this is the formula that I'm going to use to find all of these probabilities. And now you can X, what is X? X could be 0 up to 3. So replace X by 3. So go to the calculator, ask for 3, then shift C, 0, times 0.8 to the power 0, times 0.2 to the power 3 minus 0, or 3. That's the probability of 0. It would be, according to the calculator, 1 over 125, or 8 times, he said here, 8 times 10 to the power negative 3. And again, you need to go 3 units. Where is the cursor? The cursor here after 8. So I go 8, 0, 0. So this is 0.008. Or again, you use shift in 3 times. For the probability of 0 would be 0.008. Okay. Now, if you replace X by 1, then you will have a 3, 1, and 0.8 to the power 1 and 0.2 to the power 2, and the answer would be 0.096. Now, if you find probability of 2, then you will have 0.8 to the power of 2, 0.2 to the power of 1, and you have 3C2, 3C2. So the calculator will give you the answer 0.384. And finally, you raise 0.2 to the power 0, and you raise 0.8 to the power 3, and you have 3C3. Okay, so the answer would be 0.512. So this is the probability distribution of this experiment. And if you add all of these probabilities, the answer should be 1. So this is another way to ask about binomial probability distribution when he says develop or construct the probability distribution. Well, what is the mean of the binomial distribution? We studied in 5.1 that the mean is found by summation xp of x. So for this example here, I can find the mean by this is more, okay? This is not asked in the question, but I can find the mean or the expected value as usual, summation x bx. So 0 times 0.008 plus 1 times 0.096 plus 2 times 0.0384 plus 3 times 0.512. Put it in the calculator and find the answer. This will give you the mean or the expected value of this random variable. This is 384 here. So it's 0.384, okay. And 3 times 0.512, the answer is 2.4. But the question would be, is there another way? Is there an easy way here in the binomial distribution to find mu? And the answer is yes. Why? Because when he says that 80% of customers will prefer this option, and we have 3 customers, so why don't you multiply 0.8 times 3? And then you will get also 2.4. That's the answer. All right. So when we deal with binomial distribution, there is an easy way to find the mean, which is NP. You just multiply N times P. This will give you the expected value. Also for the standard deviation, square root of N times P times Q, where Q is 1 minus P. Remember that the variance is sigma square, and you can find it by multiplying N times P times Q. Let us take one example. If a binomial distribution applies with a sample size of 20, find the probability of 5 successes. Okay, probability of 5 successes. So X is 5. If the probability of success is 0.4, so this is P. All right, how to find probability of 5? In Cx, which is 5, times P, probability of success, to the power 5, times 1 minus 0.4, which is 0.6, to the power 20 minus 5, which is 15, and I can ask the calculator 20C5 times 0.4 to the power 5 times 0.6 to the power 1/5, and the answer would be 0.07. So this is the probability of 5. All right. The probability of at least 7 successes. At least 7 means the minimum is 7, means greater than or equal to 7. So probability that X is greater than or equal to 7. Okay, X runs from where to where? N is 20. So X starts from 0 to 20. Number of successes could be from 0 to 20. So how to find probability of X greater than or equal to 7? I need to find probability of 7 plus up to probability of 20. I can use the calculator to find this probability easily, or also I can say 1 minus probability of X less than or equal to 6. Okay, and I can use the calculator to find this one. Anything. I will use the calculator here. So how to write this? I will write it summation P of X, where X is from 7 to 20. That's it. And now I write the definition of P of X. What is P of X? It is 20, because 20 is N, Cx, because X is changing from 7 to 20, times 0.25, this is the probability of success in this case, to the power x. 1 minus 0.25 is 0.75 raised to the power 20 minus x. You can use the calculator and find the answer. What is the expected value? The expected value is the mean, and it is n times p, so it's 20 times 0.2, so it is 4. What is the standard deviation? It is sigma, and by definition it is square root of n times p times q, so it's square root of 20 times 0.2 times 0.8, because q is 1 minus 0.2. And if you multiply 20 times 0.2 times 0.8 under the square root, you will get 1.8, approximately 1.8. That's the standard deviation. Given a binomial distribution with n equals 8, p equals 0.4, what is the mean? Well, the mean is n times p, so it's 3.2. What is the standard deviation? Well, by definition, it's the square root of n times p times q. So n is 8, p is 0.4, q is 1 minus 0.4, which is 1.6. So I multiply 8 times 0.4 times 0.6 under the square root, and the answer is approximately 1.4. The probability that the number of successes is larger than the mean, all right, probability that number of successes is x, so x larger means greater than the mean. What is the mean? If you go to the first part, we found that the mean is 3.2. So he is asking about probability that x is greater than 3.2. I have to know the possible values of x. Okay, n is 8. X number of successes. So number of successes could be from 0 up to 8. So what is this probability indeed? He's asking about what? X greater than 3.2. So I start from 4 plus up to what? Up to 8, because the last value of x is 8. And I can find this again using the calculator. I write it summation probability of x, where x is from 4 to 8, and then I can write it from 4 to 8 and write the definition of px. What is the definition? N cx p, which is, what is p? I think 0.4. Yeah, 0.4. 0.4 times x, 0.6, which is 1 minus 0.4 to the power 8 minus x. Use the calculator and write the answer. What is the probability that the number of successes is within plus or minus 2 standard deviations of the mean? What is this? What does it mean? Number of successes, x. Mean, mu. X is within plus or minus 2 standard deviations of the mean. So we need x to be within this distance from the mean, 2 standard deviations. So x minus mu, the distance between x minus mu is less than or equal to 2 standard deviations. 2 standard deviations. This is what he meant by x is within plus or minus 2 standard deviations. When you have the absolute value, it's 2 sigma. So what do we know? We know that mu is 3.2, and we know that sigma is approximately 1.4. So I need x minus 3.2 with the absolute value to be less than 2.8. Now, if you remember in 0, 0, 1, or we know that absolute value of x less than d means negative d less than x less than d. So x should be between negative d and d. So here we have x minus 3.2 should be between negative 2.8 and 2.8. Now, how to solve this inequality? I have to add 3.2 to all the three sides. So if you add 3.2 minus 2.8, you get 0.4. So 0.4 less than or equal x less than or equal to 2.8 plus 3.2, and this is 6. So these are the values. I need to find their probabilities. So I need to find the probability that x is between 0.4 and 6. Well, what are the values of x again? The values of x are from 0 to 8. So I know that x from 0 to 8, I need x to be greater than 0.4. So I will start from 1 up to 6. So I need to find the probability from 1 to 6. Again, I can write them as summation px, and x is from 1 to 6. And I then write the definition of px, which is n cx times p, which is 0.4 to the power x times 0.6 to the power 8 minus x. And I use the calculator and I find this probability. Finally, I believe question 532, use the binomial distribution in which n6 p.3 to calculate the following probabilities. At most 1 means it doesn't exceed 1. So it has to be less than or equal to 1. So find probability of x less than or equal to 1. This is probability of 0 plus probability of 1. You can find it easily. At least 2, at least. So the minimum is 2. So x should be, in fact, greater than or equal to 2. So we need to find probability of x greater than or equal to 2. You can say it's 1 minus probability of x less than or equal to 1. So you can say it's 1 minus probability of 0 minus probability of 1. You have to subtract 0 and 1, and you can, this is already here. So if you want, you can write it like this. Okay, if you write it like this, and the answer in part A, put it here, and this would be the complement of this. More than 5, I need the probability of x greater than 5. You can see x runs from where to where, n is 6. So x is from 0 to 6. So he is asking actually about probability of 6 only. So use the binomial formula once and find the probability. X is less than 6. Well, probability of x less than 6 means from 0 to 5. From 0 to 5, everything but 6. So I can write this as 1 minus probability of 6. And the answer of part C, you put it here, 1 minus that answer. So this is the complement also of part C. Let us solve this question. A national retailer has tracked customers who visit its website and determined that 37% will make a purchase from the website within 6 months of their first website visit. So what is this? Probability. And it could be probability of success. Of what? Of customers who make purchase within 6 months. Okay, 8 people, so this is n, who visit the website are selected. So each one of them make a purchase or not. Okay, that's the experiment. Determine the expected number in the sample who will make a purchase. So making a purchase is the success here. So what is the expected number? N times P. So 0.37, that's P, times 8, which is the number of people, and the answer would be 2.96. So this is the number of people who are expected to make a purchase. Calculate the standard deviation. Standard deviation, square root of n times P times Q. Q is 1 minus 0.37, and that's 0.63. And now multiply under the square root 8 times 0.37 times 0.63, and the answer would be approximately 1.4. So the standard deviation is 1.4. Calculate the probability of 2 or fewer. So x is less than or equal to 2. Making a purchase. So he's still talking about the people who are making a purchase. So it is probability of 0 plus 1 plus 2. If you want to use the calculator, it's okay. You can write it probability of x, where x from 0 to 2. And then you can write the definition of px, which is n, and n here is 8. Cx times 0.37 probability of success to the power x, probability of failure to the power 8 minus x, and you will have the answer. That's it. Next time, inshallah, we will talk about section 5.3. Please, if you have